Assalamu alaikum. I hope all of you will be quite fine. For the today's live session, uh, I will be giving the instructions for this rip command. Previously, we have covered shell command and draft and other commands in the engineering area. The commands in the engineering area are usually used for further editing or manipulating the 3D feature which has been already created using the commands available in the shapes area. So as we have previously observed that draft command actually gives us slanted faces at some given taper or some angle, and whole command actually creates engineering holes like counter bore or counter sunk hole at stop. Rounding, it is just like fillet, as you fillet a sketch, but it is a 3D fillet. So, and other was chamfer, that means slanted edges for the 3D model. Draft is for slanted faces and chamfer actually for slanting edges at some given angle, and it had various options. So for the today is the rib command. Remember that shell and rib. Remember that shell and rib both commands are actually used for creating thin walled models. Both shell and rib are used for creating thin walled models. Means such models as having very small thickness as compared to their other dimensions. So wall thickness is very small, but as you have observed that in the shell feature it actually creates the pocket features. So we can describe that the shell command creates pocket features just like pockets in our dresses. So what is the purpose of rib command? And as we will be observing that all the commands in the engineering area are usually unavailable when there is no model. So when a model will be available, so we can observe that the necessary requirement for the rib command is that shell command must be previously applied. If there is no geometry like the geometry which can be created using the shell command. For example, you can create pocket features like using the cutout feature for the extrude command. If you use the cutout feature in the extrude command, you can also create the pocket features. Pocket features means, let us first show you what do I mean the pocket features. For example, let us create a simple model, and first of all set the planes in the isometric mode as previously in the model display, and go into isometric and click on apply and then click on enter, and no, and now for example just create a simple cube in any plane, for example here, and you can create a, for example you can say center rectangle, and set it OK, and just create a render cube. So use the shell command, and as you are you have observed that is a random thickness, let it be, and just click on this face in the removed faces area, and as you can observe that here this face has been removed. So this whole yellow you can say or orange surface, orange area, orange walls, and this bottom area is actually, we call it pocket feature, pocket surfaces. These are pocket faces, just like the pockets in our dresses. These are the pocket faces. Mean this face, and the face in the background here, and here in the background, and this bottom face means here 1, 2, 3, 4, and 5. These 5 faces are actually pocket faces. Pocket faces, just like the pockets in our dresses. So uh, such pocket faces are the necessary requirement for the later command, which is called the rib command. So, and as I have already told that such extrusion cutout type feature can be created using the cutout feature in the extrude command, the remove material feature. Remove material feature in the, for example, you can create a simple cube and you can simply draw another rectangle inside this outer cube and just cut it out up to certain depth. So I hope you have got my point. That means actually that the uh, pocket features are necessary requirement for the rib command, and rib has two types. One is called trajectory rib and other is called profile rib. One is called trajectory rib and other is called profile rib. So what is the difference between these two? You will be observing as you will be uh, looking at the demonstration. So the trajectory, as you can observe, if you closely look at the icon of the trajectory, that means a trajectory is required for the rib feature to be created, and rib, as it is analogous to our ribs in our human body, means ribs in our human body, because they are very thin materials, thin features, thin features. So, and the other type is profile rib. So let us create the trajectory first, demonstrate it first. So for the creation for the trajectory, we can observe that let us first directly launch this command trajectory, directly launch it. So click on trajectory here, and here you can observe that in the first is the placement tab. First is the placement tab, and here it says sketch. Select one item and define. So that means the first requirement for the trajectory will be the trajectory creation. Trajectory creation. So trajectory can be created externally using the datum sketch command. So select one item will be used, and if we define it at the spot, so that will be the internal sketching. Define an internal sketch, as you can observe in the side pop-up menu. It shows in the, you can see it is actually called the tooltip. So in this tooltip it is actually explaining that define an internal sketch. So you can define internal sketch or you can create an external sketch whatsoever. So let us click on define, for example. So now the important thing is that where the trajectory will be created, and for this remember that first of all the first requirement will be the uh, control of the rib height. First thing will be the control of the rib height, because the profile the trajectory for the trajectory rib command will be created on some datum plane, created on some datum plane, not on the existing faces, not on the existing pocket faces. These are existing pocket faces. The rib command will be created on a plane which is parallel to these pocket faces. For example, we can create a datum plane parallel to this internal this pocket face. This pocket face. So let us first create a datum plane. Select this face and just move it a bit, and now look at it from the front. And here in the wireframe mode you can observe, for example, this plane must be within these pocket faces, not outside, because this pocket face, this plane is out of this pocket face. So for the trajectory, remember the plane which control the rib height, this plane actually controls the rib height, means this datum plane is parallel to this bottom pocket face, this bottom pocket face. So this plane is parallel to this pocket face. So this will be the distance between this face and this datum plane will be the rib height. This will be the rib height. So up till here means up to the height of this pocket face, this plane can be located anywhere. So that will actually be automatically controlling the height of the trajectory rib. That will actually be controlling the height of the trajectory rib, because the distance between the pocket face and the datum plane will be the rib height, not the rib thickness. This will be the rib height. So I have randomly created here, for example, you can set any value here that is suitable, because I have randomly demonstrated it. So this plane has now been created. Next requirement will be, as you can observe it here, that this plane has been created. Here you can look at it, this plane which is actually highlighted in green color. So now click on again you can launch the trajectory, and this plane was already selected. So on this plane you can in the shading with edges mode. Now what you can do, you can for example look it at the top view, means the plane controlling the rib height is actually in the sketch view mode. So here for example you can create you can say a simple any random line segment like this, for example, just any random shape. Here you have now observed the very important thing that you will be noting at this feature. Let us first make the weak dimensions off. Go into the sketcher and show weak dimensions off and click on enter and no. So here you can observe that this is the trajectory. This is the trajectory for trajectory rib. This could be a single line segment, but I have randomly created 3 straight line segments. These might be curves as well. And the important thing is here that this is not a closed loop. This is not a closed loop. This is an open profile, and this has been randomly created, and even this is the ends of this trajectory are actually not meeting these side pocket faces. These are called side pocket faces because the ends of the trajectory for the trajectory are not required necessarily to be directly contacted or directly meeting the sidewise pocket faces, because perpendicular to this trajectory actually that will be the rib height. So this is just a simple line segments, means this is not a closed loop or closed area for the trajectory, for the trajectory rib command. So this is very important that you will only be creating open profile, just simple line segments. So that doesn't mean that for example I am again creating uh, a corner rectangle, for example here. So this profile is also acceptable. I am not saying that the closed loop is not acceptable. Closed loop is acceptable, but actually only these lines will be thickened. Means in the feature command, actually these individual lines will be thickened. Means uh, these are actually acting as the center line for the wall thickness, center lines for the wall thickness. And as you have observed that the thickness can be added outside, inside, or symmetrically to these edges. So this is a very important thing, that the uh, sides of the this rectangle will actually be thickened out. So how it will be working, let us demonstrate it so you will be clear. Let us click on OK. So as you have observed, as soon as I have clicked on OK, so you have observed that the trajectory feature in the preview mode has been applied. So I have rotated the model using the MMB mouse, so to show you that how this trajectory will be looking like. So you are carefully observing that this rectangle actually it was a closed loop, though it was a closed loop, but as you have observed that its sides have been thickened out. So this is a very important feature like this, that here you can observe that the direction of the thickness, that can be, it says flip the direction. So uh, so this is actually showing the wall thickness here. Showing the wall, and here if you are zooming it, so this is actually showing the wall thickness, and you can manually control it from these, like this. These are the drag points. And remember, as you are observing that I am as soon as I am increasing the rib thickness, remember this is the rib thickness, so this is the rib thickness, and at this, when preview actually diminishes or vanishes, that means this is not acceptable thickness, so the command will be failed. So you have again noted two important things, that this is the rib thickness, and this is the rib height. So rib height is actually controlled by the datum plane, which was actually placed parallel to this bottom face. So here was actually this face was actually coincident with the uh, datum plane, which was actually controlling the height of the rib, because this was actually the trajectory for the this. So in this way actually it works the trajectory. The important thing that you have noted, that the ends of the trajectory, because these were the actually side pocket faces, so trajectory was not required directly to be contacted or directly to be using the coincident constant command. It didn't require that you must contact it or meet it with these side pocket faces. So it actually projected to intersect or meet these side pocket faces. So these are important actually features, and you can say distinguishments for the trajectory rib. So trajectory rib actually accepts the open profiles as well. It actually accepts the closed loops as well, and it the ends of the trajectory are not required to be contacted or directly meeting the side pocket faces. So you must remember these three important distinguishments for the trajectory, that the profile can be a closed loop, but so that means the edges of the loop will only be thickened out. It can be an open profile, and the ends of the open profile don't require necessary to be meeting with the side pocket faces. They will automatically be projected to proceed. And remember, if there is, for example, this pocket face was vanishing, means if this pocket face was not existing, so this trajectory feature will be failed. You can observe here, I can give you a demonstration. For example, you will be observing that, for example, I am editing this shell feature here, and again in the removed surfaces, for example, I am uh, clicking here, and I am pressing control button, and to remove actually that face, I am clicking it here. Actually that must be rotated and must be brought into the foreground. So here I am just trying to rotate it, because there is some issue with the MMB mouse. So so here for example, you can with the help of mouse pad, you can approximately click here, and you use the quick pick from list option here, this surface. So must press the control button and click on OK, and here uh, you have observed this face has also been removed, and that face has also been removed. So click on OK. So here you can observe that the trajectory rib has been failed, because it's showing in the red color. So that means actually that was the pocket face, and the edge of the, you can say, the end of the trajectory was actually meeting with that pocket face. So that pocket face is actually not existing, so the command has been failed. So you can again observe an important demonstration. For example, if I am editing this trajectory, and I am for example go into the edit profile, and in the sketch view mode I am just changing its orientation like this, because this will be meeting this with this pocket face, not this pocket face, because this pocket face has been actually removed. So you will be observing, now click on OK. So you have observed that the command has been successfully applied. So that means the side pocket face must be existing. So that was a very important consideration and point, and I hope you have got it. So this is the so again, if you uh, increase the height of the datum plane, for example out of the pocket faces like this, you will again be observing that the command will be failed, as you have observed, because this datum plane which was actually controlling the height of the trajectory rib, it is out of the pocket faces, so this is not acceptable. So again you will be editing and bringing it back. Sorry, click on the datum plane here, you will be bringing it back inside the pocket faces like this, so that will be okay. So this was important feature. Again, for example, you can create uh, other datum planes for different various rib heights. So the important thing is, what is the application for these raised portions? Actually these are, you can say, for alignment purposes. For example, you will be observing that these are actually the engagement features for various lids. When some parts are assembled, actually these are, you can say, the locks in the casings, they are created using the rib features. For example, you will be observing the back cover of your mobile phones back, or I can show you here by searching out from the internet. Just wait a minute. uh, Actually I will be showing the application for various commands. So I will further be elaborating. I have got this picture after uh, various results from Google. So this is some suitable picture which actually gives you a visualization for the rib features. Just like these features, these are actually the assembling, or you can say engaging or locking features or details, raise details like this, and this as well means this feature, this is uh, having a very small wall thickness, very short wall thickness. So these details like this, for example, you can also observe this feature. If I am zooming it a bit more, as you can observe here, that these details, for example, this is a you can say pocket feature, these are pocket faces, and these thin detail, these are actually will be created using the rib features like this. So here this can also be created using the rib feature. So when you have learned this command, and you will be yourself deciding and identifying that the various features are created carefully utilizing this command. These all details are actually created using the rib feature. So uh, for example, you can use somewhere trajectory and at some other location profile rib. So the features like this are actually created using the profile rib, so that I am later demonstrating. So I have actually showed you some relevant picture that such details are actually created using the rib features, very thin details and thin racings, and these are actually engagings, or you can say when the parts are assembled with each other, so these locks are actually engaged with each other. So such details are actually created using the rib command. These locks, these all details are actually created using the rib features. So that is very very important. You can say this is inside this casing, this is actually pocket surfaces, and these all raised details are created using the rib features. So that is very important command, and you can further search out from the internet and download different pictures to visualize. So a trajectory has been demonstrated up to sufficient extent. Now let us demonstrate the profile rib. And in the profile rib, as you have observed, that there is a very close, or you can say very important difference between trajectory and profile rib. That in the trajectory you have observed that the datum plane is inserted parallel to a given pocket face, and that datum plane actually control the height of the trajectory, but in and the datum plane cannot be located away from the pocket faces or outside the pocket faces. But in the profile rib you will be observing that the datum that the datum plane may require or may not require, but the datum plane will actually be defining the location of the profile for the profile rib, that will actually be giving you the location of the profile for the profile rib. That will not actually be giving you the height of the rib. The height of the rib will be controlled by the user, or the height of the profile automatically. And the very important thing for this, the ends of the profile in the profile rib must be will be contacting or meeting the pocket faces. They will necessarily be meeting. In the trajectory you had observed that the ends were not required to be directly contacting, they automatically projected when the command was actually applied. Okay, and but in the profile rib you will have to be necessarily use the coincident constraint in the profile rib command for the creation for the profile. So let us demonstrate the profile rib, for example. So in the profile rib, for example, as a simple demonstration, for example, I can use this datum plane. This datum plane here, it is available. This datum plane. For example, I am using this datum plane as the profile rib, and the profile for the profile rib will be located in this plane. So I have selected this plane, and for example, I am using directly using the profile rib, for example, like this. So the profile will be created. So how will be profile created? Click on sketch view mode, and for example you can again show it in the wireframe mode like this. So here you can create, for example, like this. For example, this is the pocket face. So here, for example, I am connecting it between these two faces. So as you have observed that it is necessary that this profile must be meeting or directly should be contacted with these pocket faces, and the rib will be actually rib thickness will be created. This area will actually whole be ribbed. Let us click on OK, and you will be observing here that it is showing you the direction, flip direction. So if you observe it in the shading with edges mode, and if I am able to rotate it a bit, just wait a minute. You must use MMB mouse always. So I have rotated a model bit, and here you are observing that here it is showing the flip direction, so it is flipping outwards. So flip it in the inward, so that the profile rib will be successfully applied like this. So click on OK. So here like this, that this has been created. Another way, for example, we can create another datum plane, and we can observe it here. For example, again you can use, for example, you can create, for example, a datum plane. For example, you can say parallel to this face like this at this location, for example. And now click on, for example, external sketch in this plane, and again you can observe it in the wireframe mode, so that the pocket faces are clear to you or visible to you. So this is very technical. So here, for example, I am now using for example, you can use the spline. For example, this pocket face like this, and this pocket face, for example, like this. So you have observed that this portion of the profile for the profile rib is outside the pocket faces, you can observe. So this hole will actually be the height of the profile rib. So the maximum height of the profile rib will be controlled by the user. The datum plane is actually only controlling the location, because the profile will be located in this datum plane, and the ends of the profile for the profile rib must be contacted with the pocket faces directly. If they are not contacted, the command will be failed. So I have created this open profile, and now click on profile rib, for example, here, and you have observed in the, if you look in the shading with edges, so like this, as you have observed that this command has been successfully applied. So if you observe it in for example, in the right view, so here you can observe this is the profile rib. This feature has been created using the profile rib, and this portion is outside the pocket faces. So the height of the profile in the profile rib is solely controlled by the user, not with the datum plane. Datum plane only controls the location of the rib, because if the datum plane is here, the profile rib is here. If the datum plane is moved here, for example, if you are, for example, you are moving the datum plane here at this location inside the pocket spaces, and click on OK, so you will be observing that datum plane The profile rib has also been shifted. Its location has been changed, but the height is same and everything is same. So wherever is the datum plane, there will be the profile rib existing. So this is very important thing. So I hope you have get enough uh, demonstration for as an exercise. So the details or application will be later on discussed. So this is the important command. So for the time being, as a first part of this lecture, you can cover up this important feature because this is very interesting and very useful feature. So just demonstrate it and exercise it, and later on I will soon be uploading another part in which I will be explaining this pattern feature in detail, both types of, and some command from this editing surface commands. And in this way all commands will be created. After that, some applications of these commands will be covered up, complex parts will be created. mm, Thank you for the time being. Assalamu alaikum. If you have any question, you can fairly ask. Jazak.